Welcome everyone. My name is Manoa Luka, popularly known as Mano.dev, and I will be your mentor for the first session of the Cairo Bootcamp 2, organized by Blockfuse Labs. And then today we are going to have a comprehensive walkthrough of the Starknet ecosystem, understanding a whole lot of stuff. And I am pretty sure virtually everyone in this class is bullish and ready to jump on the game and learn from this bootcamp. All right. So today I'm going to be introducing you guys to Starknet, and then this is the second session. Oh, sorry, this is the first session of the second Cairo Bootcamp by Blockfuse Labs. So let's just get to it. All right, so this is me. Like I originally introduced myself, I am a blockchain developer, particularly or mostly building on the Starknet blockchain. And then that's just little about me you need to know for now. All right, so in today's agenda, we are going to be discussing a lot of stuffs like what Starknet is, why we need Starknet, why we need Cairo, what are smart wallets, understanding Starknet architecture, and then finally we are going to get the Q&A session. So for now, this bootcamp contains about 7 sessions, and this is just one of them. And in the process of this bootcamp, you are supposed to learn everything about the Starknet ecosystem, how to write smart contracts, and also how to deploy and interact with your smart contract on Starknet, how to do your front-end integrations all on Starknet, and build a full-fledged dApp by the end of this bootcamp. So that should be the agenda from now to the end of the bootcamp. But for today's agenda, which is our first step out of the 7, we are going to be going into introduction to Starknet. So let's just get to it without any further ado. We have wasted so much time already. Okay, so instead of starting with what is Starknet, let's start with why Cairo before I go down to explain Starknet for you all. And then a lot of people are going to get confused and say, it's a Starknet bootcamp. Why didn't we start from introducing Starknet to know what it is? Anyways, we'll do that later on the course. But for now, let's understand what is Cairo and why Cairo for now. So that's the first question. So what is Cairo? So Cairo is a programming language that is designed to leverage the power of mathematical proofs for computational integrity. Just as C.S. Lewis defined integrity as doing the right thing even when no one is watching. So I took this definition directly from the Cairo book without changing a single iota of any word, so that I will try to maintain the definition of Cairo as to what it is. But as that's clearly explained, it is a programming language designed to leverage the power of mathematical proofs. We are going to understand that. So Cairo enables programs to prove that they have done the right computation, even when executed on untrusted machines. Nice. So that is why we need Cairo. So first and foremost, everyone by now is supposed to know that Cairo is a programming language. Now next, why do we need Cairo? So as you all know, Cairo is Rust-like, meaning it got most of its syntax from Rust. And then the most important thing about Cairo that you need to know is that it is a provable language. So what is the explanation for that? In simple terms, most programming languages that we use today, at the end of the day, need a supercomputer to be able to compile those codes that we've written down. Take, for example, you wrote JavaScript. You need a compiler to break down JavaScript for the computer to easily understand what you are trying to write. But then in the process of doing those computations, those programming languages do not generate an execution proof or a proof that the execution really occurred, if it is right or not. Those languages don't do that. Cairo is the first programming language to generate computational proof at the end of every computation. Now, a lot of people will start asking, they say, why do we even need to prove that the computation is correct at the end of the day? Or why do we need computational proof? Why don't we just go with the regular languages we know? After all, JavaScript is not doing bad. After all, Rust is not doing bad. After all, Solidity is not doing bad. So why do we have to create Cairo? And then remember, I told you guys Cairo is Rust-like, meaning it derives most of its syntax from Rust. So a lot of people ask themselves, why don't we just use Rust to write the smart contract, since already Rust is being used for writing smart contract, right? I know those questions are already going through your head. But then why Cairo? So simply because of those computational proof that is being generated at the end of the day. That is why Cairo was being created. And this is a simple reason, and I'm going to explain it with a simple scenario. So imagine that your country, maybe your country, Nigeria, or from those of you joining in any other part of the world, is actually fighting with another rival country. So let's say Nigeria is fighting with Ghana. And then at the end of the day, Nigeria has a bunch of missiles that they want to launch and then destroy the whole of Ghana with it. This is just on the lighter note, you know. They want to destroy the whole of Ghana with it. And then, so you are the programmer that has been tasked with that job to write the code that when the button is being triggered, is going to run a computation and then take the whole missiles and then deploy it directly to Ghana so that we can be able to destroy our enemies, right? Okay. So now imagine that, and then remember that for your program to run successfully, it has to run on its supercomputer, which is like a compiler for it to run. And then the machine is going to understand what is happening at the end of the day, and is going to give the command to deploy the missile. So imagine that the supercomputer that we are trying to make this computation in exists in Ghana. And then Ghana owns the programming language that we are using to write to be able to deploy these missiles to them. Do you think it's going to be possible at the end of the day? Or is Ghana going to allow Nigeria to deploy those missiles at the end of the day to go against them? Not at all. That's just a simple question. Simply because if we try to run the computation, the supercomputer exists in Ghana, so Ghanaians can easily know that, hey, these guys are trying to deploy a missile here. And then they might even choose to change the coordinates and then make the coordinates to make the missile at the end of the day to launch in Nigeria and land in some other part of Nigeria. And at the end of the day, we might end up killing ourselves. So this is just a real life scenario to explain why we need computational proof. So most of the time, we write code, and then this code gets computed, and then we just believe the computer. We don't care to know if the computation was really right, or if it really goes how we wanted the program to run. We really don't know. We just depend on another person's computer or a supercomputer to run the computation for us, and whatsoever result it gives us back at the end of the day is what we work with. So that's why we have computational proof, or that's why they brought Cairo at the end of the day. So that after every computation, a proof is being generated to be sure that, yes, everything that has been computed by this supercomputer is correct. And so in this case, when Nigeria is trying to launch the missile to Ghana, and then it has been successfully, we run the computation, if there are any mistakes or any problems, some things have been tampered with on the way so that the missile is going to land in some part of Nigeria. If it has been done, when the result is being sent back to we, after Cairo has done the computation, the result has been sent back to us, the computational proof is not going to be correct. And with that, we are going to know that something has been tampered in our code, or this is not the result that we are expecting at the end of the day. Are we clear? Just like in a simple analogy, you depending on a calculator, and then you type 2 plus 2. And then at the end of the day, your brain doesn't know what 2 plus 2 is. So if the computer tells you 6, or the calculator tells you 6, you have no option but to believe that 2 plus 2 is 6, simply because you don't know what 2 plus 2 is. But if you know what 2 plus 2 is, That is, you can be able to verify the computation. If the computer gives you 6, if the calculator gives you 6, automatically you are going to know this is a wrong computation, and then you cannot go with that answer. Are we clear? So that's just why Cairo, what Cairo is, and then why Cairo needs computational proofs at the end of the day. So let's proceed. All right, so what are some of the features of Cairo? So number one, Cairo creates provable programs, like I first explained, right? Provable programs, meaning after the program is being run, a proof is being generated to show that, yes, this program is correct, everything went on fine. Cairo also runs on the Cairo VM, so which stands for Cairo Virtual Machine. So for those of you that are coming from the Ethereum point of view, we are no longer talking about the EVM again. Now we're talking about the Cairo VM. And then the syntax is highly inspired by Rust. And then it's, for those of you that have written Rust, Cairo is similar in the same ownership model as Rust. You know, Rust works with an ownership model, right? Same thing as Cairo. Just few things being changed. Cairo is also strongly typed. It works with traits and macros, same thing as Rust does. And then Cairo can be used outside of Starknet. So this is one of the great uses of Cairo also, and why you can build your whole career as around Cairo. Like I could remember initially, a lot of people were concerned, people that first started running Solidity and the likes of it. While running Solidity, your concern is going to be Solidity only exists on the EVM, right? Which is the Ethereum virtual machine. So that means if the EVM doesn't exist, Solidity doesn't exist. So imagine you as a developer building your whole career around Solidity, and then the EVM no longer exists. So where can you place the value to what you have learned or to the programming language that you are writing? So a lot of developers have this concern. Like I, for one, when I'm trying to learn a programming language, I don't just learn a programming language. I learn a programming language simply because there is a need for it, and I might be needing it subsequently in most things I do. So just like Cairo, unlike other programming languages for writing smart contracts, Cairo is not used for only writing smart contracts. Cairo can be used for writing normal programs, just like how we can write Rust programs, just like how you can write JavaScript programs. You can also use Cairo for that, not only for writing smart contracts. So that's why they say it can exist outside of Starknet. Yeah, so I saw someone raising up their hands. We are going to be having a Q&A session. So pending when we get to the break and the Q&A session, try as much as possible to jot down your questions so that I'm going to be taking it at that point, and then everyone is going to be in sync with what's happening. And then if you are raising up your hands, you can do well to just drop it down so that I don't get confused. Thank you, Daniel. All right, so you've seen the basic features of Cairo, right? So if you still have doubts in your mind whether you want to be a Cairo developer or not, I would advise just go into the river all in and you are safe. And even though Starknet no longer exists and we cannot use the language for writing smart contract again, you can also use Cairo that you've learned to be able to write other programs. So you are in a safe space. And that's why I chose this image to show you. The guy here is doing magic, right? So Cairo is a magical language. So if you want to do magic, do well to jump on Cairo. So let's proceed. All right, so to the big question of the day, why Starknet? What is Starknet? All right, so what is Starknet? So Starknet is a validity rollup. Big word there, validity rollup. Let's mark that. Validity rollup also stands for ZK rollup. ZK stands for zero knowledge. Most of you must have heard of zero knowledge. Most of you must have heard of validity rollup. So it's a layer 2 network that operates on top of Ethereum. And subsequently, not only on top of Ethereum, Starknet will also soon be scaling Bitcoin, and is going to be running on Ethereum and also Bitcoin, right? So you see more reasons why you have to write Cairo and why you need to learn from Starknet. But for now, it operates on top of the Ethereum blockchain, enabling dApps to massively scale without compromising on security. So that's why we need Starknet. Starknet is a layer 2, is a roll-up built on top of Ethereum. And I'm very much aware that everyone on this call is already familiar with the trilemma problem. So if you don't know about the trilemma problem, do well to Google search it. But then a simple overview about the trilemma problem is, the trilemma problem is the problem faced by most blockchains. And then this is a single problem of whereby a blockchain cannot contain these 3 characteristics that I'm trying to mention. A blockchain cannot achieve these 3 characteristics. Number 1, security, decentralization, and scalability. Hardly for it to say blockchain to integrate these 3. It's either you choose between security and decentralization and leave out scalability, which is what Ethereum did, or you choose scalability and security and leave out decentralization, which is no longer a decentralized blockchain, right? Or is no longer a blockchain. Or you leave out the security and go with scalability and decentralization, and then you become the blockchain that has the most hack ever, right? So that's what it can be. You can choose inside of these 3. So Ethereum chose security and decentralization, which is the 2 most important things. They didn't care about scalability. And that's why we have a lot of roll-ups today. So these roll-ups are here to provide scalability and then build on top of Ethereum that already has decentralization and security. And Starknet is not doing anything much different from what these other guys are doing. Starknet is offering scalability, but as a volatility rollup. So we'll go deep to understand volatility rollup. Don't get too attached for now. So Starknet achieves this by bundling transactions into off-chain computed stack proof. So this proof is then submitted to Ethereum as a single transaction, resulting in significant high throughput, faster processing time, and much lower costs, all retaining the robust security of Ethereum settlement layer. So that's just the job of Starknet at the end of the day. So at first, Ethereum was, a lot of people say Ethereum is slow, Ethereum is expensive, Ethereum is this. Now, this is the reason why Ethereum is slow, because Ethereum is not scalable. Now, Ethereum has to take a lot of time for it to be able to propagate a particular block of transactions. And then before this block will even get accepted into the network, a whole lot of computation has to be done again, which takes a lot of time. And this has to happen serially. So this is the simple reason that makes Ethereum slow. So most of these rollups, what they do is, hey, instead of we computing these transactions on Bitcoin, or is it because Bitcoin is getting to 106,000? That's what I'm calling Bitcoin. So instead of we running this transaction on Ethereum one after the other, and everybody has to wait on a queue, and then the transactions are being slow, and everything is tight, everybody is waiting, people are getting fed up, and they are saying, what is even the need of we building on the blockchain? Why don't let's just go back to our centralized authorities? So this roll-up came up with the idea of, okay, why not let's bundle these transactions off-chain? So off-chain meaning that the transactions are not going to be bundled on the Ethereum blockchain. So computation are going to be done off-chain so that it's going to be faster. And then thousands of these transactions are being bundled together. So imagine we, instead of making one transaction up to 1,000, we bundle this transaction, make them or run these transactions off-chain, bundle all of them, and then send a single stack proof to Ethereum. So at the end of the day, it's just one transaction at the end of the day. So 1,000 transaction is going to get represented by one transaction on Ethereum blockchain. So that's how they were able to achieve this scalability, by running this transaction off-chain, bundling them, sending them to Ethereum so that they get settled on where it is being secured and much more decentralized. This might sound confusing for now, but we understand what is happening under the hood. So, like they say, this proof is then submitted to Ethereum as a single transaction, resulting in significant higher throughput, like I mentioned. So, no need for all this. So let's move. So this is the L1 scaling problem. So in traditional L1, like Ethereum, this one makes Ethereum slow. So we all know that Ethereum have nodes that validators, or they are the same as nodes, right? Or validator nodes, and then these guys are the guys that propagate these blocks to the blockchain, so that it can get added to, or propagate the blocks, and then the blocks get added to the blockchain. So the work of the validators, they take transactions from the mempool, add those transactions into a block, run those transactions, execute them, make sure that they are all correct, and then they propagate it to the blockchain. So this is what happens in normal L1. If I am the validator here, and then I run this particular block, and then I say the new state of Ethereum is 42, and then I propagate it to the network. This is what makes the network slow. Now, every single validator on the network, we have to run that same computation that I ran. He has to run that same computation to verify that the state of Ethereum is really 42. So imagine I run this thing one, and then this whole total about how many, about 100 validators have to run these transactions one after the other, run the block one after the other to be sure that everything is correct before it's going to be fully get accepted on the blockchain. So that's what makes it slow. So Starknet sat down and talked about this. Hey, what is the best method? How can we make this faster, cheaper, and easier? And that's why I explained Cairo at the end of at first before coming here. So I'm going to give you guys the explanation now. So in Cairo or in Starknet, when a validator, in this case, we are going to call them sequencers, but let's say a validator for now, when he runs this particular computation and then wants to propagate the new state of the blockchain, and then he says this is the state. The state of this blockchain is 42. Nice. So, and then remember, we are now using Cairo to write our smart contract, right? So when he does that, the state is not just finally being computed, but after the state is being computed, it is being computed together with a proof that the new state is 42, and this is the proof that yes, it is 42, right? Then this is going to get propagated to the network and off to the other validators. So these other validators have to run these stuffs now to be sure that it's correct. But now this is a catch. Instead of these validators running these transactions or running each transaction and the block one after the other, they are only going to try to verify that proof. And then verifying that proof is very, very easy and doesn't even take any much computational power at all. So that is what makes the Starknet blockchain and then the scalability very, very fast, so that everybody can easily just verify the computation. Is the computation correct? Yes. If the computation is correct, we don't need to know what happened inside of the transactions, what happened in the whole block. That is just a whole waste of time, and that's what's making Ethereum slow. So all you just have to do now is the computation is valid. Yes. Good to go. That means every other thing is valid. And then this computation takes very short time to validate it. Are we clear? So let me see your emojis if everyone is clear. And then if everyone understands how Starknet is trying to scale Bitcoin now, and the reason why Ethereum is slow. All right. So let's proceed. So at the end of the day now, why Starknet? So a lot of people say there are a lot of bunch of blockchains, but why Starknet? And that's one problem. I've taught a lot of people, and then that's one thing you see people, students are facing at the end of the day after they finish learning from the Ethereum blockchain. and then now they want to go and build on other blockchains, and yes, basically just confused because we have hundreds of blockchains existing today. I don't even know which one is the best for you to build on. So here's why you need to build on Starknet. Number one, higher throughput. Number two, faster processing time. It processes transaction very fast. Number three, much lower costs, all while retaining the robust security of Ethereum settlement layer. So now, instead of you running a particular transaction on Ethereum for $5 or for $2 or even more, people have run transactions. I have a snapshot of a transaction I ran. It was around $42. And then what I was trying to take out of my Ethereum wallet was just $50. So imagine I have $50 and I have to pay gas fee of $42 to take $50 out. So at the end of the day, I only have $8. So that's how I had to wait. And I waited for days until when the transactions, the network is no longer clogged, and then things are now a bit cheaper. Then I made the transaction for about $5, and then I had $45 at the end of the day. But in Starknet, even though you are trying to move thousands of dollars from one place to another, or trying to run transactions with high computation like games and the rest of them, it is very cheap because of the off-chain computation that is being done before it is being settled on the layer one. That's why it's cheap. So instead of we running 1,000 transactions and each of these transactions is paying $5, let's say on average, that's at the end of the day, we'll end up spending $5,000 to run 1,000 transactions. Instead of we doing that, why not let's run this 1,000 transactions off-chain, and then these transactions, we will just send it down to Ethereum to run as one transaction, and we'll just pay $5 for 1,000 transactions. And then this 1,000 transactions, we now share the cost of paying the $5. And then at the end of the day, you might see each transaction, the cost of running it off-chain will end up being 0.001, 0.002, 0.005. And then it's not taking a fraction of anything that has to do with the traditional system, or anything that has to do with, sorry, I have to take this again. So it doesn't take out any much burden from the person which has been running the transactions. Because to be honest, that is that's one of the things that is hindering the massive adoption of the blockchain today. If you check back subsequent years, before you have to make a transactions, you have to pay fees, and then these fees are freaking high. So people tend to run away because the normal system is not charging them high. Why are you bringing a system that is charging us high? Right? The best way for you to sell a particular market to somebody is to give the person proper advantages that will outshine the current system that the person is using. Are we clear? Perfect. So, and then another thing, Starknet has native account abstraction. For those of you coming from Ethereum, you have the account abstraction. Some of you have tried to build smart accounts and the rest of them. Now, in Starknet, every account is native. Every account is a smart contract. We are going to understand that as we go. Another pain point of Ethereum, we keep hearing, hey, smart contracts are not upgradable. Everything it has been deployed. Some people had to come up with a standard called like the diamond standard to, as in they had to bring a lot of ways, look for ways to game the system so that smart contracts at the end of the day are going to be upgradable, because human beings are not perfect. Even though we are perfect, ideas keep evolving as the day goes by. So if I write this smart contract today, tomorrow I might have a different idea that might make it better. So in Starknet, we have native upgradability. It is built natively into the system. And if you see the way upgradability is done in Starknet, trust me, you will just laugh about it and realize that this is the best chain to build on, because everything has been made simple for a dApp developer. Even for people who want to build a roll-up, because right now the SN stack is currently available. So native account abstraction and then native upgradability. This is why you need Starknet in 5 simple points. If I have more, I'll keep telling you. if you keep reading, you keep discovering more. And as you keep knowing, those of you who probably heard about the bootcamp from Twitter and seen Starknet on Twitter, you keep hearing people say Starknet has the best tech, Starknet has the best tech. This is the best reason why. Now, if you compare this with other blockchains, you'll see that most of them do not have this. Yeah. So now, understanding rollups, because I've tried to explain rollups. I told you guys Starknet is a validity rollup. And so people are confused. What is rollup? What are we rolling? Yesterday was Mali Day. What are we rolling, right? Today is 12th May, so we're not rolling anything, but I'm still calling what's it called? I'm still calling validity rollups here. All right. Oh, so some people relate to the joke. So we have Malians in the group. All right. So what's a rollup? So rollup scales L1. Anything that scales in layer 1 is a rollup. So by moving majority of the heavy computation off the base layer. So the base layer in this case is Ethereum, right? So instead of executing transactions one at a time on the L1, rollers execute them on a layer on top of the L1. I've explained this one, where it is cheaper. Then they bundle numerous transactions together into a single compressed summary and submit it to the L1 for verification. That's just the work of rollups. So the work of rollup is scalability. Okay, Ethereum, you cannot offer us scalability, right? But you can offer us security, you can offer us centralization. Okay, that's fine. Why not? Let's build rollups, and then we are going to offer this scalability to make things cheaper, better, and then thus bring a lot of user onboarding. So, what are some of the pain points that rollup brings? For Ethereum developers, it brings cheaper transactions. Very cheap. I've said this. Faster processing time. This is like the third time I've said this. And then finally, enhanced functionality. So, how many of you have been building on Ethereum and you experience things like stack too deep? How many of you have experienced stack too deep? I can remember back there with my friends, we even turned it to a joke. Stack too deep. So stack too deep is when the compiler wants to run computation on a particular function or the functionality of a smart contract, but then it's too heavy for it to run. And then it has exceeded the stack, or it has exceeded all the power that the stack can be able to carry. So it tells you stack too deep, meaning, oh, I can't run this computation. No. It's like giving a small boy a very big rock to carry, or giving him 10 kg. Or you are 50 kg and you're trying to go and carry 200 kg. How? So that's it. So those guys now abstracted those heavy computations. So hey, you want to run heavy computations on the blockchain? Fine. Come and run it on an L1, on an L2. And then finally we send the computation back to an L1. And then security is being maintained. Scalability is achieved. Everybody is happy at the end of the day. And all our computations can be done on the blockchain. So many of you that have been coming from Ethereum angle, you understand that this is a very big pain point that has been lifted for everyone. Because there are a lot of apps we are trying to build, but you will hear people say, hey, it cannot run on the blockchain. This can't work on the blockchain. But we are trying to move towards a decentralized world. How can we go to a decentralized world if a lot of things that cannot be run on the blockchain? Why? So rollups are solving a lot of problems and are solving a lot of pain points. So let's move. But then there are two different types of rollups. In as much as they are trying to achieve the same thing, they are trying to do scalability at the end of the day, there are two types. So people came up with two different methods of achieving scalability. Now, this is the junction where you have to pick which is the best for you. And then I'm going to be asking a question after this. And then the people that give the correct answer or give a question that or answer that doesn't suit to this bootcamp, I think we'll just walk you out so that you can join other roll-ups, right? Yeah, but it's okay. You guys can just learn. It's just on lighter notes. All right. So first and foremost, optimistic roll-up. Yeah. So this roll-up operates under the assumption that all transactions submitted to the L1 are valid by default. So, you know, I told you the work of a rollup is to bundle transactions, run the transaction off chain, bundle all of them and send it to L1, right? So in optimistic rollup, if they run 1,000 transactions, they bundle it and then they send it to the L1, which is Ethereum. On default, this their rollup, we assume that every single transaction is correct, every single transaction is okay, no fraudulent anything, to just send it. That's what it does. And that's why they call it optimistic. You know what they say about optimistic? If they say you're optimistic, what do you mean? It means you are everything is yes, 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 yes. You are okay with everything, right? That's why they call them optimistic rollups. Simply because they are okay with every transaction. Until when proven otherwise. Right? So to prevent fraud, they incorporated a dispute resolution mechanism. So everything is correct until proven otherwise. So they incorporated a dispute resolution mechanism that allows anyone to challenge the transaction in question with a certain time frame up to a week by submitting something known as a fraud proof, which proves that the state was incorrect. So if the validator validates and say, hey, all this thing is okay, like how we explained in the first chapter, you know, in Ethereum, all of them have to verify that this is okay, this is okay, this is okay before they accept it to the blockchain. But these guys now, once he propagates it, they will say no problem, they will collect it, propagate to the blockchain, and then wait until when somebody raises a fraud proof. So there's a 1 week time frame for them to be waiting. Hey, 1 week, we are waiting. Oh, is this transaction? Does anybody has anything to say about this transaction? Just like how if you've been to marriages, the pastor will say, what now? Whosoever has anything to say against this marriage, say it now or forever hold your peace, right? And then that short time is being there's this short period of time, this short silence period, whereby the groom and the bride are praying in their mind for nobody to obstruct, right? So that's the same thing that happens here. So it's like that same wedding scenario. So it's been propagated to the blockchain, and then we are waiting for somebody to say, hey, I have something to say. Oh, this is a fraudulent transaction. So if a fraud proof is being generated, then it shows that this is incorrect, and then I don't know what happens. Whether it's being reverted or what. I haven't gone deep into optimistic rollup. Simply because from the day one, I love the idea of validity rollups. Now, here's why. Validity rollups, on the other hand, require the operator to submit a cryptographic proof that attests to the validity of every transaction in the batch, along with the batch itself. So while optimistic rollup is waiting for fraud proof, validity rollup works with cryptography, works with mathematical computation. If that computation is correct, it means every single transaction in that is correct. So I chose mathematics. I'm a mathematician. Though I don't like mathematics much, but I chose mathematics in this case. And then once this cryptographic proof has been generated and everything is computed and is being correct, automatically it gets propagated to the blockchain. And then that cryptographic proof is what's now going to be validated by other validators, and everything is good to go. So once the proof is correct, everything is correct. So now let's ask the questions. How many of us like optimistic rollup over validity rollups? It's two things. So Palang is going with optimistic rollup. So Palang doesn't have trust issues, or Plank, he doesn't have trust issues. Yeah. Okay. So how many of us are okay with validity rollup? Let me see your hands up. All right. So write your questions down. We are coming back to it. Now, another most important thing now, smart wallets. So most blockchain accounts are externally owned accounts, which are EOAs that have to go through some particular ways before they are being, you all know the method, right? a private key is generated, before a public this is done, before we get the account address and what have you. That's EOA for you. But then in Starknet, we have what is called smart wallets or smart accounts. So what are smart accounts? So a smart account is an account that allows users to sign transactions with the Touch ID or Face ID, execute multiple transactions in a single transaction. So on Starknet, every wallet is a smart wallet, meaning there are no EOAs. So we are building, they are all built with account abstraction. So for the Ethereum guys now, there are no account abstraction. It's not different from the normal account abstraction that you know. The same account abstraction, same functions that have been executed inside of it. So instead of we having externally owned accounts, every single account in the smart contract every single account on Starknet is a smart account, meaning every account is a smart contract. And thus, this gives rise to more features. This gives rise to accounts having much wider use cases and the rest of them. For those of you that also followed the Petra upgrade, which is the recent Ethereum upgrade, you are going to notice that Ethereum is currently bringing smart accounts also. So gradually, they are trying to give away EOAs, simply because with EOAs, the algorithm to generate the private key, the public key, and the rest of them can be bypassed by quantum computer. And you know that's the greatest fear of every developer. That's the greatest fear of every blockchain, of every developer too. Quantum computers. So quantum computers can be able to break all those. And there's nothing like, I have my private key. I'm the owner of the private key and this. I can only be the person to sign the guy. Once quantum computers come and then they crack it, automatically you don't have access to your money. Your money is not your money again. So already, Vitalik saw this. I think he created a blog about it even before the Petra upgrade. And that was why there was a need, because we have to run away from EOAs before EOAs consume us. But if you realize, Starknet has already been working with this for long. Starknet didn't have EOAs for long. Right? So you see, the world is coming to Starknet gradually. Yeah. So that's just the two things. That's just the main thing you need to know for now. Starknet doesn't have externally owned accounts. Every single account is a smart account, which gives it more flexibility, more use. Smart accounts also can help users sign transactions with Touch ID, with Face ID. They can also execute multiple transactions in a single transactions and what have you. Plenty things. So in Starknet currently, we have two most popular wallet providers, which is the first one, Argent wallet. Most of you must have heard of it. And also Bravos wallet. So these are the two most popular wallets on Starknet. Currently, we are having recent integrations with wallets like Kepler. So Kepler also integrating with Starknet. MetaMask also, they're also integrating with Starknet. And then we have cartridge controller. So cartridge controller is mostly a wallet for gaming, but it gives us access to the blockchain easily. So we'll understand this much better as we keep going. But the two most popular ones are Argent and Bravos. You can also work with Kepler and MetaMask. All right, so decoupling accounts abstraction. So we have the signer and an account. So first and foremost, who is the signer? The signer is a device that signs the transaction, identifies users with the private key. That's the work of the signer. And then the account is a smart contract on Starknet. And then it holds the assets, it verifies the signatures, and then it executes transactions with multi-core. So that's just the two work of both of them. And then both of them join together now. It's a smart account or a smart wallet, right? All right. So we're going to do a very short, simple exercise now. And then in the process of this exercise, I'm going to take some questions Then we go to the last 2 segments, and then we are out of here. This is supposed to be a short session so that we don't take long and we don't bore you guys about Starknet. All right, so the first exercise is for you all to install Bravos or Argent, any of the extension. Just go, you can get it in Chrome, in Brave, any of them. Just search for Bravos or Argent extension. You can, first and foremost, for you to install it. Next, I need you to create an account on Sepolia or Mainnet, anyone. But for now, let's work with Sepolia. Then we are going to try to fund your wallet. So your wallet that has been generated, you try to fund it. Then we try to look at the transaction lifecycle on Starknet. So let's see how transaction goes from one place to another. Then we try to deploy the account, and then we check the account source code and see what it looks like at the end of the day. So we're going to be doing this in a very short period of time. So let's just take a few minutes. 5 minutes should be enough for that. You guys can do the installation while I take questions. So now, anybody that has a question can shoot. Let me get
a good morning, sir.
Good morning.
Good morning, sir. And is the validity roll-up and the zero knowledge roll-up, are they the same thing?
Yeah. Validity roll-up and ZK roll-up are the same thing.
Okay, sir.
So the last time I said ZK, validity roll-up, then I put ZK in brackets.
Okay.
Nice. All right, who else? Accurate is already done with the installation. Nice. So you guys will see the cheaper and everything I'm talking about. So I don't have to be the guy stressing myself to doing long talk. No cho. Let's show workings. So how many of you are currently going through the installation? Can I see your hands? So you can bring down your hands. We only have 5 minutes for this. And then so I'll continue exactly at 9:50 or even before 9:50. Or we can proceed and you guys will do it after the class. But I wanted us to see some stuff before we proceed. Yeah, Christiana, let's get your question.
So please, I don't know if you could explain this view in detail.
Okay. So EOA stands for externally owned account. Can you please mute your mic? EOA stands for externally owned accounts, and then these are our normal regular accounts. Like if you open your normal MetaMask account, that's what's regarded as EOA. So this account goes through a particular process whereby private keys generated for the user, the public key, and then hence the account address. It goes through a particular process for this to be able to achieve. So this is basically what's known as an externally owned account. But then, yeah, that's just it. But you can also Google search and read more about EOAs, because that might not be like a perfect explanation for you. So Christiana, I hope that was probably explained by the question was explained. So externally owned account are controlled by a private key. That's their main work. All right, so now let's have a look. Where do I open? So I have my Bravos, I have my Argent wallet here. I can also choose to put this on the side so that everyone can see properly. So this is my Argent wallet. I have some Stark in it, I have Ethereum in it. But then let's go through the transaction life cycle of a normal Starknet transaction. So if you create your account on Argent, at the end of the day, you should be left with something like this. try as much as possible. You can switch your networks, and then you can switch it either to Ethereum or mainnet or DevNet if you are building. And then, mind you, for those of you who are coming from Ethereum point of view, let me explain this to you. You guys need to know this. You know, in Ethereum, if you create a particular account, say for example, I create this account on mainnet, it's still going to be the same account on testnet. So I add another network, it's still going to be the same address. Like that, it keeps going on Ethereum. Just like this. If I open my MetaMask now, let me explain what I'm talking about. I don't forget this password. But there's nothing inside, so I'm not scared. Okay. I get money. Okay. So, like if, for example, in Ethereum, this particular account has been created, right? So this account, even though you have to switch another network, at the end of the day, it remains the same account. Let's say I switch to Polygon, it's still the same address, it's still the same private key, but it's just that it's going to be controlling a different network, right? But when it comes to people like Argent, Bravos, the account that is being generated on mainnet might not be the same account that is being generated on testnet. And thus, the private key might differ. So don't think because you have created a Sepolia account and then somebody is telling you, send me money, send me your account, mainnet address, I want to credit you. You just copy the Sepolia account and send. Otilo, don't go. Like, bye-bye. Who is asking for my private key? Somebody should arrest this guy. So that's just a simple explanation. So here, as you can see, Sepolia. This is my Sepolia account. So let me try to collect faucets. So to get faucets, those of you that are used to going to Alchemy, you don't have money to pay 0. Blah 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 blah. No need for that. Let me just take you to the Starknet faucet. So with this, you can be able to collect, I think, about 150 stack every. I've forgotten. Before it was every hour, but I think now they made it every 24 hours. You can collect that stack or ETH. You can collect 0.02 ETH, right? Yeah, I think so. I can also collect 150 stack every 24 hours. All you just have to do is post your address in there and then everything will work. Also, I don't know why this. I have to verify this. Let me just wait for the verification to go through. Or somebody should send me. No need to send me your address. Let me just send them. Okay. This opportunity to collect stack. So paste it and then I request tokens. Yeah, please, we have passed this question and answer time. Yeah, so if our token is successfully credited, we are going to see the message below, and then we go further to check the transaction lifecycle. So when you say transaction lifecycle, it simply means what happens. What happens when you click sign? What happens when you click $5, 5 stack, send to Apollo, or send to Planck, or send to Alcana? What happens? That's the life cycle. Okay, yeah, I think I've been credited, but it didn't show. Yeah, this is it. I've received this stack. All right, so what happens behind the scene and the rest of it? So let's click here and then check it out. So I think the transaction details exist here. Everything exists in the transaction hash, and I can easily see it. So transactions in here move in like 3 different stages. First and foremost, received, to say, yeah, your transaction has been received, though, so that you know. Next, accepted on L2. So accepted on L2 means that your transaction has successfully been computed, has been bundled in our rollup, and then it has been accepted. And currently it is being sent to the L1. So now look at this. Accepted on L1. Accepted on L1 has not been checked yet. So we have already only passed 2 stages. Received and then accepted on L2, but then it has not been accepted on L1 yet. Simply because there are different processes the transaction have to go through. First and foremost, it has been received by the sequencer. The sequencer has successfully bundled it together, send it to the prover to run the computation and generate the proof. And then the prover is now going to send everything finally now to Ethereum, which there's a smart contract that exists on the Ethereum called the verifier. Now, every single rollup you see has a smart contract that exists on L1, which does the final settlement. So this is the current stage that we are now. Our transaction has been accepted, has been computed, have been batched, bundled, and sent to the prover. The prover has computed that every single transaction is correct, and he has sent the computational proof to the verifier. So the verifier now is now going to verify that computational proof to be sure that every single transaction that was batched is correct. Everything is right. If the proof that exists in L2 is the same with the computation that exists in L1, then it's going to get accepted on L1. And thus, the circle is complete. And the circle of running a validity rollup is successfully complete. This process takes roughly some few hours. I think for some time, there was time it was around 7 hours. It's dropped down to 5 hours, and currently about 3 hours now. So, and then the sweet thing about this is that the more transactions are on the block, the more transactions that have been bundled, the lesser the time for it to be confirmed on L1. So the more people, the lesser the time for confirmation. Another sweet part of it. So at this point now, the computation is being done to verify by the validity rollup if our computation is going to be accepted or not. But in the case of an optimistic rollup, this process, like in this our process now, it's going to take, this process is going to take us up to, like, before this transaction is going to be accepted, it's going to be around, let's say, what's it say here? He's saying about 5-7 hours. He's doing some countdown here. But it might even take less than 7 hours. But let's leave it at 7 hours, right? Which is fine. But when it comes to your normal optimistic rollup, this process of after the batching and sending it to the L1 for the final verification takes 7 days at minimum, up to a week. Haba Nigerians. So we don't need any comparison again. Simply because of this, the mathematical computation has helped us cut down all those complexities, shut it down for us to how many hours? 7. That's what maximum. I'm just working with 7 hours because that's what I see here. So that I don't say something and people say, it's contradicting with what's on the board. But I know it takes lesser. And then, so this is the advantage over optimistic rollup that takes 7 days for this to get validated or verified at the end of the day. Right. So we have successfully seen the transaction life cycle. Then finally, you guys can choose to check out your account to see whether your account is deployed or not. So for you to know your account is deployed, I can just copy the address. So on Starknet, the 2 most popular scan are either Voyager or Starkscan. For those of you coming from Ethereum, you're already familiar with Etherscan. Those of you building on Base, you're already familiar with Basescan. Those of you building on Leaks, you're already familiar with Block Scout or what? Yeah. So, but here we work with either Voyager or Starkscan. All right, guys. So if I want to know if my transfer, if it's deployed, all I just have to do is copy my address here, paste it, and then check. So some people will say, why do I need to check if it's deployed? Now you have forgotten. Your every account is a what? A smart contract. That's the simple answer. To go back is talk on account creation. Someone should help him out. All right, guys, so this is it. This is my account, and for me to know my account is deployed, it has already said it's deployed by, this is when it was deployed easily. So if your account is not deployed, it will tell you. You see, my account has been deployed, it has run a bunch of transactions already. I even have plenty test dollars inside of there, right? So that's how you know that your account has been deployed. So enough of smart accounts, smart wallets, and the rest of it. Am I moving too fast, guys? Just let me know. Or is it because we have a lot to cover? Am I moving too fast? Am I moving too slow? All right. So I don't know where Aklo is confused. I think we leave that to the question, but I can see your message here. It's based on what I just said. You're talking about, is it the transaction lifecycle that you are confused, or the, what's it called? Transaction lifecycle or account deployment? So I will just assume it's the account deployment. So if your account is not deployed, as soon as you search it on StackScan, it will still show you, but you will see not deployed there. So the best way for you to deploy an account, mostly on Argent, all you just have to do is fund the account with Stack or ETH, mostly Stack. If you fund the account with Stack, that is, you went to receive faucets. As soon as you fund the account, you try to make one transaction. As soon as you make it, maybe you send money to someone, your account automatically gets deployed, except if there are extreme cases. No, you don't have to run any transaction. You don't have to run maybe a dedicated transaction to deploy the account. Though there are functions deploy account that exist, right? But in this case, all you just have to do is just fund the account with Stack and then send the Stack out to someone else. It's going to deploy the account for you, except if otherwise. This mostly works in Argent. I don't know about Bravos. But if there will be an account for deployment, if there will be a function to tell you there will be a function that might exist to tell you update the contract. So if you click it, to now run the function. But then before it runs, remember you need gas fee. That's why you have to collect Stack at first. All right, guys. So let's proceed. Back to the slides. So we are done with smart wallets, and we're done with this short exercise. So to the final stuff of the day, we are going to be looking at Cairo architecture, a little about Cairo, a little that you need to know. Nothing much serious, because what I'm going to be introducing now in the next session, the next tutor is going to introduce all of that. So there will be no need. All right. So Starknet architecture, what does it look like under the hood? What happens? Now let's look at it. So as a developer, when you first write your code, this is your laptop and this is the Cairo program, right? So as soon as you do this, first and foremost, it compiles down to Sierra. So in Ethereum, you get told that, hey, your Solidity code gets compiled down to bytecode, and then bytecode is what the EVM understands. Almost similar thing with Cairo, but just that Cairo have about 2 layers. So first and foremost, Cairo first goes through the Sierra. compiles this Cairo code down to Sierra. Sierra stands for safe intermediate representation. And initially, it wasn't even part of the whole thing. It wasn't part of the architecture, but it was later introduced. Because if you notice, there we have Cairo 0 and Cairo 1. So for those of you that want to learn Cairo, and then you are thinking of using ChatGPT, if you're not using like the very much paid version, even some paid versions, they will not write the real Cairo for you. When you ask questions, it will give you questions based on Cairo 1. Because that's what he understands. So Cairo 1 didn't have Sierra. Cairo 1 was Python-like before they switched to Rust-like. So Sierra was one of the main reasons why they introduced Cairo 1. They didn't just bring Cairo 1 because they thought about saying, this contract or this language, we want it to be Rust-like. No, that was not why. They brought it simply because of Sierra. And we'll understand that subsequently. So once the laptop, your program compiles down to Sierra, the supercomputer then compiles Sierra. So this Sierra is being sent down to the supercomputer. The supercomputer then breaks down the Sierra and compiles it down to CASM. So CASM stands for Cairo Assembly. So CASM is what the Cairo VM understands. The Cairo VM understands Cairo Assembly. Ethereum Virtual Machine understands bytecode. The Cairo VM understands CASM, which is Cairo Assembly. Cairo Assembly has to be break down from Cairo program, which is the normal code we write, down to the Sierra, safe intermediate representation, down to CASM, which is Cairo Assembly. And then finally down to the Cairo VM, which is the Cairo Virtual Machine. So the Cairo Virtual Machine is the one that does the execution. And after the execution, everything is the trace of that particular execution is being sent to the prover. The prover then does his own stuff to be sure that every computation is correct, and then it generates a proof. So when the prover generates that proof, the proof is what is being sent to the verifier. Now the verifier exists in L1, which is Ethereum. And then the verifier then verifies everything, and then we are good to go. So in your normal smart contract language, first and foremost, it compiles the program, but then it breaks it down to bytecode. And then bytecode at the end of the day will just run inside the EVM, but no proof is generated. Whatever is being generated, whatever the result is what is going to be sent to the view to L1. And L1 will accept it like that. But in Cairo, two things have been generated. One, the validity proof. Two, the results. So after you finish running every computation, like me, sending money from one person to another, when every computation is done, the prover is going to send me the results. Hey, it's successful, everything went fine. But at the end of the day, the proof of that particular computation is being sent to the verifier. That's what happens here. You see the two results? This is me, the end user. And then this is the verifier. Two things. Are we clear? Is everyone okay? As Yoruba boys go to count. Show her okay. Show her okay. They know hear that one. Is everyone okay? Is everyone fine? Can we go? Perfect. So there are no Yoruba people in this class. All right. Let's proceed. So, writing smart contracts in Cairo, deploying smart contract in Cairo moves in simple stages, which I'm going to be explaining. Almost before you can deploy a smart contract in Cairo, the smart contract first has to be declared. Now, remember, this architecture is just an overview. From subsequent class, this is going to be introduced properly. We just want you guys to have a simple overview of it for now. So, declaring a smart contract. Before a smart contract can be deployed on the Starknet blockchain, first and foremost, it has to be declared. Now, what is declaration? Because a lot of Ethereum people don't know what declaration is. All they just know is deploy. Call the deploy function and it works. Right? But here they are saying, hey, we have to go through something. Now, declaring a smart contract in Cairo produces what we call a class hash. Now, a class hash is a particular hash that is being generated from the particular source code of that smart contract. So let's take, for example, if you write an ERC20 token today, an ERC20 token is going to have, when you want to deploy that ERC20 token, first and foremost, you have to declare it. So declaring that ERC20 token is going to give you a class hash. So the class hash is going to contain everything that has to do with ERC20 tokens, the functions and the rest of them. So with that, when a user wants to deploy a smart contract, Starknet is going to ask the user for that class hash. So it is that class hash that is going to be used to deploy that smart contract. Now, here is the catch, and where is the sweet? If you write a smart contract or an ERC20 token in Starknet, all you just have to do is, after you declare the class hash, any other person wheresoever in the world doesn't have to write that contract again for him to be able to deploy an ERC20 token. So the person can use that particular class hash and then deploy the instance of another ERC20 token instead of writing the code from scratch. So class hash gathers all the smart contract with similar functions, similar state variables, similar functionalities, and the rest of them, and generates one single hash. And that hash can be used to represent those contracts over and over again. So if you want to deploy an ERC20, you agree with me on Ethereum. If I want to deploy an ERC20, I have to go to Open Zeppelin. Maybe I don't want to write the code from scratch. Copy the code. After I copy the code, I come and paste it. After I paste the code, I then try to deploy. Then it's going to give me a contract address. But in Starknet, you don't have to do that. All you just have to do is get a particular class hash for ERC20. If you get a particular class hash for ERC20, you can deploy multiple versions even without having the single line of code. Now, some people will ask, where can I get this class hash? You can find it. Me, I haven't tried to find a class hash. This is what I do. If I want to deploy an ERC20 token, I might just do a normal way, the way I do it before in Ethereum. After I generate one of the class hash, that is it. If I get a class hash, I will just keep that class hash and hold it. That's my class hash. In short, it will not even generate the class hash for you. Why you are trying to deploy, except you change some functionalities within the ERC20. If you are trying to deploy it, the class hash is going to tell you that a class hash already exists for that source code. Because it, first and foremost, it's go and check, hey, do we even have similar smart contract like this? If we have similar contract, why do we need to collect this guy's smart contract and keep it in our space again? Why not let's just give him the class hash that exists and for him to use it to deploy? So that's what it will do. If you try to deploy an ERC20 token or try to declare it, it's not going to give you a new class hash. It's going to tell you that the class hash already exists, and then it will provide you with the old class hash. Then you can copy that class hash and then deploy your instances of ERC20 tokens, and you are good to go. So that's what happens. So first and foremost, we declare. After we declare, we get the contact class, and then with the contact class, we can be able to deploy to get the instance of that particular smart contract. Are we clear? At this point, at this junction, I think I'm getting exhausted. And thank God we are at the second to the last slide. All right, so this is it. First and foremost, all those long English I was explaining, this is just the summary at the end of the day. So Cairo is a provable programming language. Syntax is similar to Rust. It compiles to Sierra, which stands for Safe Intermediate Representation. The sequencer compiles Sierra to Safe Chasm, which is Cairo assembly. And then fixed transactions are included in blocks. Sequencer always compensated no DOS vector. Now, back to my first question. Why was Sierra introduced? I will answer that. So you don't have to answer it. I don't expect you to answer it for me. Why was Sierra introduced? This is it. At first, when you run a particular transaction on Starknet, a particular computation, Starknet doesn't handle, Kazim doesn't handle what's it called, failed transaction. So with that, Starknet cannot keep track of failed transaction. But then a computation was run. It's just that it failed. And with this can give rise to DOS attack, denial of service. Because somebody can keep running failed transactions, which is not being run or propagated, and the network doesn't know how to handle it. And then you other guys are trying to run real transactions and it's not going to work out. So that's why Sierra was introduced. So that it's going to be the layer that first handles every failure cases. It runs everything, which one fail, which one not fail, gathers in all the failure cases. It still sends those failure down. So that failure is also going to be handled and be stored on the blockchain. And that's why today, if I open my wallet, where is it? I think I saw it somewhere. Oh, guys. Do I have to go back? Yeah. I saw it somewhere, but I don't want to stress myself to go and look for it. So I wanted to show you guys what a failed transaction looks like, but let's just proceed. Right, so that's what happens at the end of the day. Cairo and Sierra handles all the issues that might come up at the end of the day, all the errors, any failure cases, it still handles it, propagates to the blockchain so that failure cases can also be recorded. Right. So with this, I've spoken a lot, and then it's now time for you guys to speak. So thank you very much for listening, attending my TED talk. Thank you for those that came late, those that came early is fine. And then this is my best way of welcoming you guys to the Starknet ecosystem, which to me is the best ecosystem anyone can find itself. So I'm bullish on you guys, and I hope to see what you guys do in the space while you proceed in the course of the bootcamp. So this might be your first lecture. Do well to attend the rest. And I bet you from now to the end of this session, you are going to be a full Cairo developer. Yes, no hidden charges, no extra fees, nothing attached, only just jollification, courtesy of Starknet. So let's take your questions now. Hit me. Yep, Apollo, let me take you.
So it was based on that when we think the transaction, that transaction life cycle, whereby he said it has to be deployed or something like that. I was actually confused there. I don't understand that side in that transaction life cycle. And how can we get the recording of the class?
Yeah. Everyone is getting the recording of the class for sure. Yeah, so this, I think you are referring here. That's this place, right? Where I said deploy an account after the transaction lifecycle.
Yes.
So here is the cache. Every account on Cairo, remember, we said it's a what? A smart account, right? Smart accounts are not far from what we know, built with the normal account abstraction we know in Ethereum. But this time around, smart accounts are smart contracts. And that's why they need to be deployed. So first and foremost, they might be pre-generated, but not deployed for usage. So when you first create your wallet, you haven't made any interaction. Nothing has been done at all. So account deployment has to be made. Are we clear? So the transaction lifecycle has nothing to do with the deployed account. In short, if your account is not deployed, I don't think you can be able to even see a certain transaction lifecycle. Yes, because no transaction has been run, except you will check transaction for another person's account. So I urge you guys to check the different ways, because the best way I know whereby accounts can be deployed is only with Argent. I will advise you guys to check Bravos. So I'm using a Bravos wallet too, alongside an Argent wallet. but I haven't taken time to check the processes around Bravos. I just did the sign up process, open the account, and the rest of them. But then accounts need to be deployed. Else, if you generate an account that's not yet deployed to show you. Now let me try to look for an analogy. Okay. Let me try to add another account. What's happening? All right, let me just use a standard account instead of adding a smart account. All right, so this is a new account which I created. So let's try to check if this account is deployed or not. So I go to Voyager. Okay, let's check out Starknet, because some of these things might be funny at times. Now, when you are building in Starknet, you have to be patient too. Yes, because things are kind of new here, and even though we have to appreciate the progress, things have really gone mature from the time I started building in Starknet to now. I will tell you for sure that a lot of things are really gone mature. So if some things are trying to give you a headache, just try to use an alternative. Then you understand how the ecosystem works. Don't just yell at your, what's it called? Because you can't find a particular stuff. And this account is not found. So does that mean this is not deployed? Let's ask ourselves that question. I don't think so. Because I'm supposed to see it here, whether deployed or not. Except things have changed. Because things change every day. One last time, and then we try to do the deployment. Okay, not found. So let's assume this wasn't deployed. But you can see that an address exists here, right? Good. So now, let me copy the address and then fund it from this account. Yeah, this guy, right? Let me fund it with 9 stack. Right, so it has been sent. Let's confirm here. Yeah, we have received stack. Now let's try to search this address on StackScan. Okay, it's already here. Let's refresh and see. Uh-oh, what's happening? Yeah, it is on Sepolia network 7E. Guys, let's just hang on a little. Let's see. Okay. To be honest, I can't seem to say what the problem is. But just know that this address exists already. Maybe probably later it's going to get propagated and we can be able to see it. but it didn't give me a smooth flow to explain what I wanted you guys to see. Let me try one more stuff. Oh, can't find it. But is that a mainnet address? No, it's a Sepolia address. Right, so it's not up till now. So probably before the next session, we might explain why that is, but we are supposed to see this on the scan. But it didn't work, so no problem with that. So let's take more questions. But I'm just sure you are clear, right? So the price of deploying an account on Argent, send money, take it out. Yeah. So MP has a question. She said, he or she said, is it the fraud proof that causes about the 7 days delay in the optimistic rollup compared to validity? Yes, it's because of that time frame. So like I told you, like your name exists, optimistic. They are very optimistic about any transaction that comes in until when proven otherwise. That's how their rollup was being built. So it has to take a 7-day window for a fraud proof to be generated. So, you know, if it takes maybe only 3 hours, the person that will generate the fraud proof might not even see or know that a certain fraudulent transaction has happened. So that's why they are giving that long time frame. So that no matter, bad as bad, the guy don't already see, and within 7 days, you must be on your phone. No matter where you go, within 7 days, you must be available. Except you don't die or you don't travel. Your phone will be around. Or they kidnap you. So that's just a simple reason. But validity rollup doesn't need to wait for fraud proof. It works with mathematics. In mathematics, we just do the comparison. Is this correct? Is this correct? Good to go. I remember it's zero knowledge. So 2 of them don't really have to know. You don't have to know what the competition is here, what's happening here. All you guys know, all they know is that between the prover and the verifiers, at the end of the day, we are going to arrive at the same result. If we arrive at the same result, everything is correct. If we don't arrive at the same result, it's not. Yeah, questions, guys. All right, Prince, hit me.
So based on my understanding about this deploying account, is there any time you want to like go to Sepo, like create new accounts for you and the rest more like the way Solid works, whereby you can switch networks, about. But in Cairo, you just have anytime you want to switch to a network like Sepolia, account is generated.
Yeah, so this is how it works. You will have a mainnet account. Then for your development purposes, you have your dev account. You also have your Sepolia account. So all these accounts just need to be created once, except you want to create another one. But what I'm saying is don't use the same account for all, because mostly in Starknet, mainnet varies from testnet addresses. Mainnet varies from testnet addresses. Like now, let me give you a simple explanation. Look at my Argent now. Let me go to mainnet. Check these accounts, copy. Then I go to this scan. This is a mainnet account. Let me search it on mainnet first before I will come back to Sepolia. So if I search it on mainnet, can you see? This account exists on mainnet. But watch out. If I switch to Ethereum, if I switch to Sepolia, what will happen? See, contract not found. Are we clear? Unlike here in MetaMask, where I can just copy this address and go to Etherscan. If I go to Etherscan, I search it. See, I can see it on my mainnet, right? Let me verify my Scarb. So I can find the address here. And also when I switch to Sepolia, so let me just put Sepolia in front of this. Sepolia dot Scarb. Check it out. The same account is also being found. But in Starknet, it's not the same. So try as much as possible to always check. At times, it can generate the same for you because it has happened for me. I have an account here in my Argent that the first I generated your minute, it gave me the same address. I generated on the person, gave me the same address. But still yet, like I said, I could still go hook up. But I don't know what, maybe something. Probably it's looking very similar, and I don't even know whether there's a difference between two of them. Right? So that's just it. So more questions before I leave. Yo, tell me, let's take your question. Hit me. No questions? All right, so so I don't waste your time. Yeah, Lucky, let's take your question.
Okay, go ahead. Someone here ask question.
Sorry. Hello?
Hi.
Okay. Okay, I have a question, sir. My question is, the Cairo have a smart wallet, and we have other wallets like Trust Wallet, Digit Wallet, and others. So I want to know why do they choose to build their own smart wallet that is different from other wallets, and what makes their own outstanding, or what makes it different, what makes it more valid than other wallets? That is what I want to know.
All right, great question. I think that's a very interesting question. But some questions now, some of your questions I can't answer them. Like number one question, why they choose to build their own wallet. So first and foremost, all you need to know is that these wallets are not directly under Starknet, right? Just like how MetaMask is not directly under Ethereum. These wallets are independent companies on their own that decide to integrate with this particular blockchain. So Argent, and you know that first and foremost, with a simple explanation, wallets normally are used to like manage our keys and also help us have access to the blockchain. So in this case, at first, you cannot use MetaMask to interact with the Starknet blockchain. You need a Starknet account or a Starknet wallet that exists for it to be able to interact with the Starknet blockchain. So that's why their own different wallet was needed. And I guess at first they were really looking for collaboration, or collaborations didn't come in, and those guys went ahead to build. Though Argent that I know of was first at foremost was even built on Ethereum at first. Yes, Argent was an Ethereum wallet before it was migrated down to Starknet. So that's just the reason why they built their wallet, so that you can have easy interaction with the blockchain. It's this wallet that can help you interact with the Starknet blockchain. But currently now, like I said, new wallets are coming in. MetaMask is currently integrating them. And Kepler is currently integrating them. And those ones are not wallets that were using Starknet before. So everything boils down to the wallets themselves. Argent and Bravos chose to integrate Starknet. And that's why they are Argent Starknet wallets. Next, down to your second question. which is quite an interesting one. What makes this wallet completely different from every other wallet? Now, as the name implies, smart wallet. They didn't just call them smart wallet because they are smart. Just like how some dev we say smart contract and then you end up writing a dumb contract, right? This is the key catch. Initially, EOAs are accounts that are only managed by a private key, and they have specific limitation. That is, EOA's work is just that managing of accounts, signing of transactions. That's just his work at the end of the day. So better things or better UX can be created in Web3. And that's what brought about smart accounts. Smart accounts are smart contract accounts. So this time around, these smart contract accounts are more flexible. Because it's a smart contract, it exists like a normal program. It exists like normal code. So we can be able to embed more functionalities into it that can make it better, much flexible, much sweeter, much easier for users to use. So that's why smart wallets were created. And like I said, at first, EOAs are managed by private keys, right? Meaning if you lose your keys, everything is gone. But in smart accounts now, sweet things or sweet involvement are coming into the space now that we can see. Like you can be able to recover your account. It wasn't possible before. Now you can recover your account with your email. How sweet. Like my Argent now. I'm using an Argent account. And trust me, even though my passphrase is missing, even though you go away with it, all I just need is my email to have access to my phones back. And that's courtesy of smart wallets. You can also have guardian key. Someone can have control over your assets, not only you. Because it's a thing of concern. I usually have this concern most of the time when I think about debt, and then I'd be like, wait, most of us are keeping our money in decentralized entities or in blockchains. And then, what if something then happens to me? And then I die, and then my family don't even have access to this private key. This money is gone and locked forever. You know, unlike a traditional banking system whereby you can have your next of kin can just go to access bar, say, yeah, I'm Manuel's next of kin. And they will just check, okay, Manuel registered him as a next of kin. So give him Manuel's money and he's good to go. But in normal EOAs, if I don't give you my private key to store for me, which is not advisable, for you to give your next of kin your private key while you are still alive, it means the money is gone. So the only way this can be achieved is using this smart wallet. So with smart wallets, this NASA coming in like guardian key, signer key. So you can give right or access to some people that, hey, even though you are not available, those people have right to interact. Those people have right to recover your wallets for you in case of your account getting missing. Don't only look at it in case of next of kin. You know, email works in such a way whereby you might attach 2 emails to a particular, maybe you attach an email to your email. And then anytime that your email is lost, they are going to send you a recovery through the other email that you attached. Same thing with this guardian key that they are working with. You can have your own smart contract account, have your own smart wallet, but then you tied it together with a guardian key or with a guardian wallet. Maybe it's your son's wallet, maybe it's your wife's wallet. And then something happens, your phone got missing, something got missing, you don't have access to your wallet again. Those people can be able to trigger a call to help you verify, to help you to recover your wallet back. So you see why smart accounts are needed, smart wallets are needed at the end of the day. And lastly, to the most important point, EOAs are prone to attacks by, what's it called? By quantum computers. And quantum computers very soon are coming. So people have already started saying it. They said a small chip of quantum computer was created, I think. Was it by which people? It was published some time back. Around this year, not long ago. The algorithm that is being used to generate these private keys, this public key that gets stored within these wallets for you in normal EOAs, it is prone to attack in the next few years. Probably this year, because somebody might have quantum computer and not even show us. And allow us until when a lot of people have their asset on chain, then you bring it out and attack. And trust me, technology is evolving every day. And on the bad side, not on the good side. People working on the bad side of technology are more than the people working on the good side of technology. You have to know that. Because the bad side even ends more than the good. And that's why you see a lot of attack, by bits. Let's not go to all those stories at the end of the day, right? But that's just the simple reason why. And if you have your money in an externally owned account, I advise you go take them out. Advice. But all thanks to the Petra upgrade, now we are going to be seeing a lot of changes, and we need not worry about all these things at all. Because smart accounts are going to manage these things for us. Our accounts are smart contracts. So if it's not you, if it doesn't verify that it is you, it doesn't work. So thank you. Hope you are cleared, Mr. Saka. Yeah.
Okay.
I take one more.
Yes.
Okay.
I have one more question, sir.
Okay.
Yes. We discovered that some blockchain built on Li, while others built on L2. So I'm a little bit confused. Can you share more light on the L1 and L2?
Yeah, I think that was like the main order of the day. That was what we've been discussing from like the onset, why we need Starknet and the rest of them. So first I talk about the trilemma problem. Now, layer ones, a blockchain face this particular problem, which is the trilemma. Simply put, every blockchain is either the trilemma problem has to do with security, decentralization, and scalability. But then all blockchains cannot implement these three, and that's the trilemma problem. So L1s, most L1s like Ethereum chooses to work with what's it called? Chooses to work with scalability, security, and decentralization, which is the most important, leaving scalability behind. Now, what is scalability? Which is the most important question. Scalability is like or how can I put this? I need a dictionary explanation. Scalability. That's something to be able to enlarge or open to accommodate more. Yeah, that's the word. For something to be scalable, meaning it can accommodate more. Now, currently, the amount of people on chain are not even up to 1 billion. And Ethereum is slow. Ethereum can only process 3 transactions per second. I've been at 15 transactions per second when it first came into being. Do you know how many transactions people are running on a second basis? So with 3 transactions per second, we have 7 billion people on Earth. If 1 billion people or 1 million people make transactions this second, it means only 3 people's own can be handled. That's a major problem. And that's the scalability issue we are talking about. So Ethereum cannot accommodate more. Ethereum can only be secured and decentralized. It cannot accommodate more. So that's what brought the rise to L2s. L2s now say, even though there's security, even though there's decentralization, if people are not getting this thing fast as possible, people will run away because the normal Web2 platform is working fine and they're not having issues. So you want them to wait in queue and sit down like someone who is waiting for a Nigerian pension? No. So they brought this method now called L2s, which are roll-ups. And then what they do is that they make computations off-chain. If they compute it off-chain, they now bring it on-chain, and then it settles on-chain to enjoy the security and the decentralization. So that's just the best I can explain this. I'm already exhausted, to be honest. And that doesn't mean I'm not taking more questions. It's just me telling you I'm exhausted. All right. So I've already dropped my Twitter handle and all. Feel free at Manu Aluka, message me on Twitter. I will reply. Don't message me on WhatsApp. I will run. Message me on Twitter. I will give you answers there. Right? Subsequently, you'll also be meeting more mentors as you keep going. And then I hope you guys have a nice day and enjoy yourself while building the Starknet ecosystem. Thank you very much for your time. And at this junction, I have to jump off the call.